Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code DTC P0116 refers to an ECT, Engine Coolant Temperature Sensor 1 circuit range performance problem, specifically for the Honda CRV models produced between 2011 and 2016. The ECT sensor plays a critical role in monitoring the temperature of the engine coolant, which is pivotal for optimal engine management. It sends temperature readings to the Powertrain Control Module, PCM, allowing for appropriate adjustments to fuel injection and timing based on the engine's thermal state. Located near the engine block, the ECT sensor is usually positioned in the cylinder head or engine coolant passage, making its accessibility vital for maintenance and troubleshooting. When this code triggers, it indicates that the ECT sensor is either reading temperatures outside of its expected range or is not performing correctly, which can lead to inefficient engine operation and increased emissions. Understanding the implications of this code is crucial for technicians in maintaining vehicle performance and safety. The ECT Sensor 1 is essential for providing real-time coolant temperature data to the vehicle's PCM. Located near the engine block, usually in the cylinder head, its positioning allows it to accurately gauge the temperature of the coolant circulating through the engine. This temperature data is critical because it directly influences the engine's fuel injection strategy and ignition timing, ensuring that the engine operates efficiently under various temperature conditions. If the sensor does not perform within its specified range, it can lead to poor engine performance, potentially compromising fuel efficiency and increasing exhaust emissions. In essence, this sensor serves as a key component in managing the thermal dynamics of the engine, and a fault with it could indicate issues that may need immediate attention to avoid further complications. Several factors can contribute to the triggering of DTC P0116. A primary suspect is a faulty ECT sensor itself, which may fail due to internal defects or wear over time. Additionally, poor electrical connections can disrupt the communication between the sensor and the PCM, leading to erroneous readings. Loose terminals at the ECT sensor can also result in intermittent connectivity issues, which may lead to fluctuating sensor data. Furthermore, potential problems within the PCM can affect how it processes the input from the ECT sensor, ultimately resulting in this code. It is crucial to assess each of these aspects methodically, as overlooking any could lead to further complications or repeated issues in the vehicle's engine management system. When DTC P0116 is active, drivers may observe various symptoms that indicate a problem with engine performance. One of the most apparent signs is the illumination of the check engine light on the dashboard, which serves as a warning that an issue has been detected. Furthermore, drivers may experience poor fuel economy as the engine may not be operating efficiently, leading to excess fuel consumption. Engine overheating could also be a symptom, as the PCM may not accurately regulate fuel flow and ignition timing based on incorrect temperature readings. Additionally, performance issues such as rough idling, sluggish acceleration, or stalling may arise due to improper fuel-air mixture. Recognizing these symptoms early can aid in diagnosing the issue before it escalates into a more serious engine malfunction. The first troubleshooting step for addressing DTC P0116 involves verifying the function of the ECT sensor using the Honda Diagnostic System HDS. Begin by turning the ignition switch to the on position, which powers up the vehicle's electronic systems without starting the engine. Once the system is active, use the HDS to check the parameters related to ECT Sensor 1. Specifically, look for the current temperature readings of the sensor and compare them to the threshold values set by the manufacturer. For this specific case, the ECT sensor should be reading more than 176 degrees Fahrenheit or 80 degrees Celsius to be considered functioning properly. If the reading meets this criterion, document the value obtained, as this will be essential for subsequent steps. If the reading does not match these standards, you will need to proceed to the second troubleshooting step to determine the cause of the discrepancy. If the ECT sensor reading did not meet the required thresholds, the next step involves deeper verification of the sensor's functionality. First, document the current temperature value of ECT sensor 1 from the data list accessed through the HDS. Then start the engine and maintain the speed at approximately 3,000 RPM, ensuring the vehicle is either in park or neutral to avoid unnecessary load on the engine. This will prompt the engine to reach operational temperatures faster, causing the radiator fan to activate. After allowing the engine to stabilize, check the ECT reading once again via the HDS. You should observe whether the temperature has changed by 18 degrees Fahrenheit or 10 degrees Celsius or more. If significant temperature variation is detected, this indicates an intermittent failure in the system, allowing you to assess whether there are poor connections or loose terminals related to ECT sensor 1 and the PCM. If no change occurs, further investigation or replacement of the ECT sensor may be necessary. The third step to troubleshoot DTC P0116 focuses on verifying the ECT sensor's behavior at high temperatures. To start, turn the ignition switch to the lock position to power down the vehicle's systems. Next, allow the engine to cool for 3 hours, which is essential for accurately assessing the sensor's performance under differing thermal conditions. Once the engine has fully cooled, turn the ignition switch back to the on position to activate the systems again. Following this, check the ECT sensor's values in the data list using the HDS once more. You're looking for similar results as before, whether the ECT reading varies by 18 degrees Fahrenheit, 10 degrees Celsius, or more under these cooler conditions. If a significant shift in temperature is noted, this again may suggest intermittent faults, whereas a lack of change would indicate a repeated failure, leading to the necessity of replacing the ECT sensor and proceeding to repair verification. After completing repairs, the integrity of the ECT sensor must be verified to ensure that the issue has been properly resolved. Begin this verification process by turning the ignition switch to the on position, which allows the electronics to activate without starting the engine. Using the HDS, reset the PCM to refresh its parameters, which is vital after replacing any component affecting engine performance. Following the PCM reset, it is crucial to perform the idle learn procedure, allowing the PCM to recalibrate its idle parameters based on the new conditions. Once this procedure is completed, check for any remaining pending or confirmed DTCs using the HDS. If DTC P0116 reappears, this could indicate that further diagnosis is needed, particularly evaluating electrical connections and terminals at ECT sensor 1 and the PCM to ensure they are secure and devoid of corrosion. If the DTC does not return, the troubleshooting process is effectively complete. In concluding the repair verification for DTC P0116, the final steps involve comprehensive checks using the HDS. Begin with confirming that no further DTCs are present post-repair. This step ensures that the initial issue has been fully addressed and there are no contributing factors remaining. Additionally, conduct a meticulous inspection of all electrical connections to the ECT sensor, ensuring there are no loose, corroded, or damaged terminals. Confirming connections are tight and secure minimizes the risk of recurrence for the stated fault. Finally, assess the performance of ECT Sensor 1 within its typical operating range, while monitoring readings through the HDS during engine operation. Ensuring consistent data without fluctuations signals that the repair has been successful, ultimately reinstating the vehicle's optimal performance. To prevent the recurrence of DTC P0116, it is beneficial to implement a regular maintenance schedule, focusing on vital components associated with the ECT sensor. Regular inspections of the ECT sensor itself can help identify early signs of wear or damage, allowing for proactive replacements before failure occurs. Attention to the electrical connections is equally essential. Inspecting for corrosion, loose terminals, or signs of wear can preempt issues that might disrupt the sensor's performance. Maintaining proper coolant levels and quality is fundamental too, as low or contaminated coolant can compromise not just the ECT sensor, but the engine's overall thermal management system. By fostering routine maintenance practices, owners can significantly extend the life of the engine components and enhance vehicle performance, ultimately reducing the chances of encountering DTCs in the future. In summary, DTC P0116 highlights a crucial aspect of engine management: the function and reliability of the ECT sensor. Understanding the role of this sensor in regulating engine performance through accurate temperature readings is fundamental for both vehicle technicians and owners. Early identification of symptoms such as engine overheating, performance issues, or poor fuel economy can lead to timely interventions, minimizing potential damage to the engine. Following the outlined troubleshooting steps methodically is key to effectively diagnosing the problem, ensuring accurate repairs are made and verification processes are followed through. By incorporating preventive measures and routine inspections into vehicle maintenance, one can safeguard against future occurrences of DTCs like P0116. Building a comprehensive understanding of the importance of this diagnostic code not only ensures better performance, but also contributes to the longevity and efficiency of the Honda CRV. Please like and subscribe to the channel. See you next time.